Hello. First of all, I'd like to say it's an honor to be here today. My name is Maria Muffaletto, and I'm here with my colleagues Matthew Brandt, Kelly Klain, and Carla Sexton. Today, we're going to be talking to you about wireless medical technologies. Thank you. We're going to discuss radio frequency identification, security, and wireless medical devices, and the future thereof. In order to best determine what defines all of these wireless medical devices and technologies, it's best to consult a global organization for health, such as the World Health Organization. So then you have to be asking, so where did it all start? How did we get to where we are today? And the answer to that question is telematics. Telematics is an umbrella term that actually defines telehealth and telemedicine. Telehealth includes surveillance, health promotion, and public health functions, whereas telemedicine includes the use of telecommunications to diagnose and treat ill health. Then we move on to what's called e-health. E-health was introduced by John Mitchell, who's a doctor, and in 2000 he said that e-health and all these new technologies were actually going to obviate telemedicine. Now, he wasn't totally ridiculous in making this claim, but at the same time we'll see that telemedicine is still utilized today. Going forward, the World Health Organization has defined e-health as the transfer of health resources by healthcare and electronic means. Now again, this is one of those umbrella terms used by the World Health Organization, and it actually is comprised of three major components. The first of which is the delivery of information, health-related information, that is, for health professionals and health consumers through the internet and telecommunications. Now, we can kind of think of this as a doctor-patient relationship, your professional, your patient, and we want to make sure that these technologies, this e-health business, is all beneficial to both the doctors and the patients. If we have devices that only really benefit one or the other, there's no real reason to have them. The second component of e-health is using the power of IT and e-commerce to improve public health services through the use of education, for example, or training of health workers. Now, there's a new term for that, which we'll get to soon. The third component and final component is the use of e-commerce and e-business practices in health systems management. We can think of health systems management as the overall healthcare of a country. So then I said, there's these three components and we have these other parts that we're all feeding into. So let's go back to what I said we'd be doing a call forward, e-learning. That's the use of information and communications technologies for the purpose of learning and education of healthcare professionals, healthcare workers. We're talking doctors, nurses, anybody else that's going to be working with patients. And then we have telemedicine, which John Mitchell said was going to be obviated, but here we are still utilizing it today. And the best part about telemedicine is really the fact that you can kind of think of this in the rural areas, places where if someone gets injured, you see them in the movies being helicoptered off. The biggest thing there is this is really for people in rural areas who can't necessarily access healthcare as well. And what happens is you utilize these telecommunications devices and are able to treat, diagnose, and help them. The next and final component that I'm going to talk about is mHealth. Now, mHealth has really exploded in the past couple of years. So what ended up happening was the World Health Organization actually formed a global observatory for e-health. When they started the global observatory for e-health, they decided that they were going to do a 6-volume series, and they were going to analyze how e-health is being implemented in a bunch of different countries. Now, since mobile health and mobile technologies have been on the rise for quite some time, they decided to dedicate one of their volumes to mHealth alone. They called it mHealth, New Horizons for Health Through Mobile Technologies. And in that volume, what they did was they defined mHealth. And the GOE states very clearly that this mHealth business is not a standardized definition. So it is actually the medical and public health practices supported by mobile devices such as mobile phones, patient monitoring systems, personal digital assistants, and other wireless devices. Through the use of these mHealth technologies, we're able to greatly increase the access to healthcare that more people have in the entire world. What ended up happening was, to determine what would work best, the GOE decided to do a survey to figure out which of the 14 mHealth initiatives were being implemented best, in which countries, what's underway, and you'll see that we can see these initiatives here. Now, when they did this survey, they decided to do the survey in a yes, no, don't know format, and they assessed up to 112 member states, and they asked, hey, what are you guys doing? How are you utilizing mHealth in your country? How's the implementation going? Is it beneficial? Is there a demand for it, et cetera? And one of the countries that actually got surveyed was the United States. So let's look at our survey. We said that despite the fact that we have the costs, which is a huge issue in many other countries, the demand, which means that the citizens want the mHealth option, and the technical expertise, which is not available in many other countries, we're actually not doing a lot to implement mHealth right now because we kind of have it on the back burner, so to speak. We have other priorities that we're focusing on. Again, think back on that healthcare overhaul that we've been working on recently. And the other thing is we kind of have a weak infrastructure as far as health is concerned. So in order to best utilize mHealth and best give the citizens of the United States that mHealth option, what the US is going to need to do is put that as a forerunner and actually focus on that more significantly in order to improve the quality of mHealth in our country. Now, one of the things I mentioned was cost. One of the biggest issues, unsurprisingly, is in low and middle income countries where they don't have the money to afford it. The Journal of Health Communication determined that low and middle income countries could best benefit from the use of these mHealth technologies. Due to the fact that we have less options for health infrastructure, we don't have the costs, we oftentimes don't have the technical expertise, it's very important that we go ahead and we implement the smaller things. Remember that I mentioned that mobile phones count as mobile health. So what we did was, they did a study in Indonesia where immediately following a tsunami, they were giving pregnant women, women with new babies, and women who were nursing the opportunity to contact their midwives. So they gave all the midwives cell phones, and I don't know, I'm pretty sure everybody's familiar with SMS services. I probably send about 50 texts a day minimum. So what they did was they took the midwives and they said, hey, text your patients. Text your patients and remind them they have appointments, they need to come in for a checkup, their child could be sick because of this, this, and this. I mean, they just lived through a tsunami. And they found that just by utilizing this simple thing that, frankly, we take advantage of all day in America, we can greatly improve health outcomes in low and middle income countries. So I want to go ahead now and bring it back to the United States and talk about cell phone use in the United States. Pew Internet Research, part of the Pew Research Center, decided to do a study on cell phone use in America. And what they found was that 85% of all adults have at least a cell phone. So that's not even including smartphones. You'll notice 53% of people actually own smartphones. So that's over half of everybody that owns a cell phone in the United States has a smartphone. And everybody loves their smartphone, right? So what ends up happening is people are utilizing their cell phones to seek out medical information. So when I say seeking out health information, I mean they're looking up, symptoms and so forth. Like, think about going to a website and typing in your symptoms, which one I'm talking about, and you're trying to determine what disease you might have, and it's a popular website. But then another percentage even is researching specific health advice. So by health advice, I'm meaning similar to the telecommunications era, where you're calling doctors, you're telling them what's wrong with you, you're trying to get a prescription, trying to get a diagnosis. So this allows you, just with your cell phone, just with your medical device, to research this information. Going forward, we see that one of the biggest trends now is mobile applications. So everybody's got their smartphone, they've got all their apps, they're super excited, and they're trying to use their apps to better their lives. We see that Samsung, first of all, they started it. Samsung came out with an app called S Health in 2012, and it came out on their Galaxy S3 phone. That was a lot of phones ago, it seems like, but what ended up happening was it was kind of a low-key, didn't really collect a lot of information, the data wasn't as great, it wasn't as reliable. So when they came out with their newer phone, they added new processors, they allowed for third-party integration, and with the S4, we got a much better phone and a much better app out of the S Health app. So of course, not to be outdone, Apple of course has to come back and say, hey, we've got a health app. So what they did was in their keynote this past month, they said that, hey, we're introducing a health app, and here's what it does. And Apple actually took it a step further, and they installed what they're calling the M8 coprocessor. The M8 coprocessor is able to track a lot more of the fitness things, that you would be doing on a daily basis. Think more like your Fitbits and something that's a wearable, like the Apple Watch, that would also collect information and data from you all day. You know, who do you know that has a smartphone that isn't with it all day? That's pretty much no one. If you've got a smartphone, that's attached to you. So the greatest thing about this technology is that you're not really doing anything different. You're going about your day very normally, wearing your watch, checking the time, and at the same time it's recording all this information. The only thing you really have to do is download that third-party application and put in all the food you're eating, and then really you've got this full-fledged health information document. The health app actually includes your biological sex, your weight, it keeps track of your caffeine intake. I mean, you name it, this thing's doing it. The other benefit to Apple's new phones, the iPhone 6 and the iPhone 6 Plus, is with this coprocessor, there's also a barometer. So while you're working out, let's say you're walking uphill or you get on the treadmill and you're elevating it, or maybe you're climbing Mount Everest today, but it's going to track that with that barometer. It's going to track that information and it's going to say, hey, you climbed a mountain today. That's pretty cool. And because you didn't just walk straight in a line, you burned more calories. Props. So that way we're able to fully utilize these apps to their best they could be. And just so you know, 1 in 5 people is utilizing these apps. And I'm not talking the apps that come loaded on the phones. I'm talking about the apps that are actually being installed in addition, those third-party apps, to those apps that come preloaded. Now that we're talking about devices and tracking and all that, I'm going to hand it over to my colleague Kelly, who's going to talk to you about how radio frequency identification is integrated into the tracking process and used in medical technologies. Thank you.
Thank you, Maria. My name is Kelly Klein, and I am excited to be here today. I will be speaking about radio frequency identification, also known as RFID, and what exactly it is. So, what is radio frequency identification? It is a data collection technique that passes product information using radio waves to a particular receiving unit. The components needed in this process are a tag that include an electric chip, an antenna, and a reader. This whole process enables supply chain visibility by doing more than the regular barcodes we are used to. Radio frequency identification tags are more precise and hold more information than a normal barcode, making them a smarter choice for retailers in the long run. There are 2 kinds of radio frequency identification tags. The first is an active tag. These require a power source, such as a battery. The second kinds are passive tags. These are the most common form, and they don't need a power source, so they are more readily available. An example using the passive tags are any type of manufactured good that is either shipped and or stored. Then comes the question, what is actually in these RFID tags? In each tag is also an electronic product code, or EPC. The EPC is a unique number that identifies a specific item. It is used as a tracking component so companies know where their items are, how many there are, and if they need to be replenished items. EPC Global Incorporated is responsible for the oversight of electronic product codes and standard specifications as well as guidelines for auto ID since tracking is involved. There are laws and regulations that have to be followed. Next is the history of the technology. Now that we know what radio frequency identification is, let's discuss how it got started. According to the RFID journal, radio frequency identification can be traced all the way back to World War II around 1934. The Germans, Americans, British, and Japanese were all using radar to detect when their planes were coming near to their bases, but they were also unable to identify if they were their own planes or if they were the enemy's. To solve this, the British started putting a transmitter on each of their planes, making it the first active radio frequency identification system. Let's talk about RFID's progression throughout the years. In the 1950s and 1960s, scientists and academics in the US, Europe, and Japan kept expanding on radio frequency identification to see what all could be doing with this upcoming technology. Companies started adopting radio frequency identification to detect if items were being paid for or not. If someone tried to walk out of a store without paying for an item, an alarm would go off at the door because the item had not been purchased, and the radio frequency identification tag sent a signal that said that it had not been purchased. This prevents theft. Each item has a bit encoded inside the product, and once it is scanned at the register, the bit is turned off and the customer is able to walk out of the doors without any problems. Companies today still use this system to protect their business and make sure that their goods are not being stolen. You'll never believe what company actually brought radio frequency identification and really made the change prevalent in society. According to the Blanchard, who wrote Supply Chain Management Best Practices, Walmart is actually the company that brought RFID forward and believed it was important. They have made the invention take off and have forced its suppliers to adopt the system, or they would refuse business with their retailers. Walmart demanded suppliers to start using electronic data interchange, or EDI, in order for transaction processes to be quicker and easier. That way, everyone would be on the same network and no one would have to worry about different transaction means. To start up using the frequency identification system, it is estimated at a total of $9 million, and that includes the tags, hardware, software, and other related services. In the long run, it is worth for most companies to pursue. Next, I will be presenting on how technology moved into the healthcare field. It wasn't long before healthcare started adopting the system. If you have ever gone to the hospital for a treatment or a test, you are familiar with the RFID tags. As soon as you register, you are handed a bracelet, and inside that bracelet that has your birthday and other information on it is a radio frequency identification system. This is attached to the hospital's Wi-Fi network. Not only are patients labeled by the RFID tags, so are the staff. Newborn babies, laundry, fixed assets, drugs, and blood. Speaking of newborn babies, let's discuss the newest technology to protect infants. An article about a health practice involving radio frequency identification focused on the system is called Hugs Infant Security. This device has two parts, a Hugs device and a Kisses device. The Hugs device is placed around the ankle of a newborn child, and the Kisses device is attached to the mother. This makes separation for the mother and baby nearly impossible and prevents children from getting switched at birth. It is the world's fastest growing and selling infant protection system and has saved 1.5 million infants each year. Once attached, the device automatically is enrolled into the system and is processed on a Windows-based PC environment. The entire system runs off of a CCTV, or closed-circuit television, that includes video surveillance and video cameras to transmit signals to the database containing the mother and baby's information. The heartbeat of the child is signaled to the conjoining computer every 10 seconds to ensure that the child is still present, and if he or she is not, an alarm is sounded to indicate that there is a problem. This device is simple to use and attaches in seconds and has no hassle or buttons or numbers. It is convenient and well suited to make sure new families are safe and in the correct hands. Infants are the only people we are keeping an eye on. Radio frequency identification is also located in all the staff badges. These badges track a nurse or a doctor throughout their shift to see when they are and where they are and what they are doing during their time there. They also detect how many times that specific faculty member washes their hands. Sanitation is a huge issue in the medical field, and this system has been a way to improve that aspect and increase the cleanliness of the entire facility. Some of the hospitals, such as the Florida Hospital Wesley Chapel, has a system that once a nurse enters a patient's room, their complete description of the nurse's name, photo, and job function is projected onto the screen located in the patient's room, so they know exactly who the nurse is and that they also feel more comfortable being around that specific person. All of this information was provided by an online article sponsored by the IT Business Edge titled 6 Ways Wire Technology is Transforming Healthcare. Equipment is also a main product that is encased with radio frequency identification. Also provided by the previous article mentioned was the use of frequency identification in equipment throughput throughout the hospital. This equipment is very expensive and highly specialized, so it is important to know where it is in the hospital and certain machines and other equipment such as IV pumps, wheelchairs, and specialty beds. These tracking devices help eliminate the time spent searching for the equipment and focus more on the patients themselves. The Shands Hospital at the University of Florida has concluded that there have been They have encountered a 98.8% reduction rate in the amount of time spent searching for equipment since this wireless technology has been implemented. The radio frequency identification chip records the temperature for which those items are encased, and it exceeds its normal temperature. It signals a computer to let the staff know that the temperature needs reset. This process saves products from spoiling and ruining their intended use. In operating rooms, a certain amount of humidity is needed, so the RFID system also monitors that and lets staff know if there exceeds a predetermined range. If the temperature or humidity gets too out of control, the equipment can fail, which causes a lot more problems and can even be deadly for patients. Now, let's discuss some of the disadvantages for this system. There are disadvantages to the radio frequency identification system. According to an article titled Storage Devices and Radio Frequency Identification Applications in Healthcare, this system is incredibly expensive to start up. As mentioned before, it takes an estimated $9 million to start up. Not all companies have that kind of money. Another issue is tagging materials such as metals and liquids. Because of these substances makeup, these make it hard to read the radio frequency identification tags. They have to be placed in certain areas at specific angles when being stored, or they will get an inconsistent read when trying to locate these items. Interference is also a concern. Forklifts, walkie-talkies, and mobile phone towers interfere with radio frequency identification systems, making it harder to get an accurate read on radio frequency identification readers. The last portion involves visibility. Since radio frequency identification systems are encoded inside products, they are not always seen with the eye, so one must have a register to get the information they are looking for. Barcodes are the opposite of this because they are readily seen on packages, making it easy to find the item they are searching for. But what about the good these systems do? On the other side of the disadvantages are the advantages. According to the Blanchard, who wrote Supply Management Best Practices, this system provides more efficient, speedier, and safer practices, not only in healthcare, but in other manufacturing facilities as well. Radio frequency identification is a proactive way to replenish stores more regularly since everything is tracked as it moves in and out of stores. It also allows for a reduction of out-of-stock issues and detects when items leave the premises without being paid for. Inventory counts are done every day instead of every 4 to 8 weeks as they have been done in the past. Automated receiving allows retailers to receive and deploy merchandise more quickly, accurately, and inexpensively. Radio frequency identification promises customers improved customer service, speedier shopping, and faster product. What are the advantages associated with medication? The drug industry, such as pharmacies, has used radio frequency identification to stop counterfeit. This procedure enhances quality as well as safety. An example is a drug called Pfizer, who inserts radio frequency identification into every one of their packages, cases, and pallets to ensure patient safety for their products. Another company called GlaxoSmithKline tags all their bottles of Trizer, which is an HIV medicine, while it is being shipped to the United States to make sure that the product is authentic and not counterfeited. Radio frequency identification and other prescriptions is beneficial because if an item is recalled, it is easier to find every item because they are already being tracked in the first place. Other benefits include error and crime prevention, cost reduction, removing tedious procedures, and avoiding infections. According to the Storage Devices and Radio Frequency Identification Application in Healthcare article, radio frequency identification also keeps track of medicine and patients, increases inventory efficiency, is able to hold more data than a barcode, and enhances security. Technology has brought us many wondrous things these past few years. Dozens of new communication devices, scores of new gadgets, and hundreds of new security issues. Next will be Matthew Brandt. He will be discussing these security issues that are directly involved with radio frequency identification.
Thank you, Kelly. As Kelly mentioned, there are issues with RFID systems that are used in healthcare. There are a number of concerns with utilizing RFID in healthcare environments due to their high vulnerability of attacks. Each RFID system has a tag as one of the components. Most RFID tags in the United States operate off of the 915th megahertz frequency bandwidth due to its ability to recognize an RFID tag from 6 meters away or more. The problem with the tag is that it will interact with any reader that attempts to read it. Because each RFID tag will interact with each reader's request, if you have a device that operates off the same frequency as the tag, you are able to obtain the information if there are no security measures in place. The reason this is an issue is because each tag can hold sensitive information about a subject, and if unauthorized readers are scanning and getting that information, it can lead to security breaches. Due to RFID tags being utilized in healthcare settings, there is a potential risk that confidential information is presented in those tags. In order to secure the information in the RFID tag, we need to implement security measures. Some security measures that are in place to help counteract these attacks are cryptography, detection and evasion, temporary deactivation with the utilization of a Faraday cage, and authentication of readers. While there are security measures in place, it is still imperative that when utilizing RFID in healthcare field, that the information stays secure and private. Now, I'm going to move on to a new component of wireless healthcare technologies, and that are wireless sensor networks. There has been a long history of medical sensing that has been used in the healthcare field. These devices have been embedded in instruments that have been located in hospitals, clinics, and homes that are able to provide a constant insight into people's physiological health. Without sensors such as thermometers, glucose monitors, blood pressure monitors, imaging sensing devices, or many other type of devices, it would be very difficult for health professionals to diagnose and treat our ailments. The term wireless sensor network is an emerging technology that has had its roots in standard medical instruments. These wireless sensor networks have the potential to transform our way of life. A wireless sensor is a very small entity of a network that has unique features attached to it. Some of these unique features are large-scale deployability, reliability, and most importantly, mobility. Now, wireless sensor networks are not unique devices to the medical field. Wireless sensor networks are utilized in many sectors of business. A term that is exclusive to the healthcare field, however, is wireless medical sensor networks. Wireless medical sensor network is a term that brings together multiple fields of research, including electronics, medicine, bioengineering, and computers. These devices can be wearable, implantable, portable, and integrated into a wide range of wireless devices. There are three noticeable advancements in technology that have allowed wireless medical sensor networks to be extremely beneficial to the healthcare field. One of the reasons is the advancement in sensing technology. With advancements in microelectromechanical systems, imaging, microfluidic, and nanofluidic devices, they are pushing towards the growth in availability to perform sensing operations that normally would need to take place inside a laboratory or a hospital. The advancement in these technologies have allowed us to create devices that are capable of performing the same level of sensing that used to be done in a lab, but now we're able to utilize them in the field, on the go, or inside home. The next advancement we see is the decrease of size and cost of sensing devices. In the past, sensing equipment was too large and complicated to be used outside of the laboratory. But with advancements in microelectronics and computers, we are able to reduce the size, cost, and complexity of these sensing devices so people can use them inside their own homes. There are four types of sensors that have surfaced from the advancement of microelectronics and computers. There are four types of sensors that have surfaced from the advancement in microelectronics and computers. The first were portable medical sensors that were able to be used in homes, such as blood pressure and blood glucose monitors. Because these devices were able to be used in home, clinicians were able to get frequent data without their patients having to commute. As we see in this slide, a home blood pressure monitor from Omron, it allows us to obtain our blood pressure daily and upload to the internet via Bluetooth. The next type of sensor we saw emerge were the ambulatory medical sensors. These sensors were small enough to allow them to be worn or carried around by the person utilizing them. These devices have allowed us to continuously monitor our health throughout our daily lives. Some devices that are included in the ambulatory medical sensors are heart rate monitors and physical activity monitors. These devices have become quite popular today in the form of wearable devices such as the Nike Fuel Band, the Fitbit, and other similar devices. Not only are wireless medical sensor networks helpful for clinicians and scientists, they allow us to continuously monitor our own health and keep track of our fitness levels without having to consult or visit a doctor. The third type of sensor we saw emerge were embedded medical sensors. These sensors have been placed inside prosthetics and orthotic devices. The sensors that have been implanted in these devices allow us to assist in caring for the elderly or the disabled. The last type of sensor that has emerged is the implantable medical sensor. These sensors allow us to continuously monitor the internal health of patients. The purpose of these devices is to monitor activities where we were previously not able to monitor through external sensing. The sensors that we implant are able to take readings and could help stop events such as seizures from happening. They also allow us to assist in brain-operated prosthetics. Because we are able to monitor continuously and internally, we are able to recognize trends and ideally stop events like seizures from happening before it's too late. The last advancement led to the widespread use of wireless medical sensor networks were the advancements in connectivity. Before wireless connections became available, sensors were constrained to connectivity through wires such as USB or Ethernet cables. But now, sensors have the ability to connect to other devices using short-range or long-range technologies. Some of the short-range connections are Bluetooth, Zigbee, and near-field radios. One example is the use of UniMob, which stands for Ubiquitous Monitoring Environment of Wearable and Implantable Sensors. UniMob is an ad hoc network whose purpose is to continuously monitor a patient's physiological state and capture that data. It also serves to alert healthcare professionals when a life-threatening ailment can be predicted. Some examples of long-range communications are Wi-Fi and cellular communications. An example that uses these long-range communications is a technology called MobiCare. MobiCare is a wide area mobile monitoring system that transmits continuous data from a patient to a specific server. These short or long-range connections allow devices to communicate with computers, digital assistants, smartphones, and the cloud. Not only do these connections allow us to see data in real time, with the use of the cloud, we're able to upload information and save it to use at a later date. These advancements in connectivity have allowed the use of wireless medical sensor networks to be utilized while we were on the move. Because of all the advancements in technology that have allowed us to utilize wireless medical sensor networks more effectively, let us take a look at some of the situations where these devices are being used. One situation where these devices are being deployed are at mass casualty disasters. The increase in mobility, scalability, and the fact that these devices can be deployed rapidly, we're able to monitor more people at a continuous rate than we were in the past. Due to these benefits, we're able to be much more effective in the field than we were previously. Another way we see wireless medical sensor networks being utilized is in hospitals and clinics. Because wireless medical sensor networks do not rely on wires to transmit information, we see a huge reduction in the number of cords that are attached to patients. Not only does this make it more easy for doctors and nurses to operate and monitor their patients, it makes it more easy and comfortable for the patients as well. We also see the deployment of these devices in the homes of the elderly. As we get older, our health deteriorates. Because we have devices that allow us to monitor our health, we're able to look at how our bodies are doing on a medical basis, and with that knowledge, it assists us in behavior changes and allows for early detection of ailments. And finally, another use of the devices is to set up large-scale field medical and behavioral studies. The ability for scientists to monitor and record from a large number of people allows us to obtain data that we were not able to in the past. Because we are able to receive lab quality of data out in the field, it allows scientists to make long-term studies on a wider range of people in areas they previously did not have access to. Despite all the numerous positive applications of wireless medical sensor networks, there are some downsides. Because wireless medical sensor networks operate wirelessly, some challenges include reliable data transmission, timely delivery of information, fast event detection, and security. Security is a big issue because of the sensitive information that is being transmitted. Because of this information that is being transmitted, people are able to sniff packets out of the air, and if they choose, they can use that information in any way they please, most often maliciously. People can be at risk of losing their jobs or public embarrassment if their private information is released. There seem to be more ways for hackers to steal information that is being sent over the air than we are able to protect it from. Some of the most common forms of stealing information are eavesdropping, interception of information, modification of information, routing information to areas where packets were not originally to be sent, and masquerading attacks, which can send resources to areas where they aren't needed or to places where people don't exist at all. One important type of attack that we have to take into account for are denial of service attacks. Or DOS attacks. DOS attacks are critical to counteract because wireless medical sensor networks need a constant stream of data in order to be used effectively. A DOS attack is especially dangerous because it affects multiple levels of the open system interconnection, or the OSI model. DOS attacks can affect the physical, the data link, the network, and the transport level, and the application layer. Because DOS attacks have many ways to disrupt the transmission of data from a sensor to a network, it can be very detrimental to doctors and patients if that information is not sent. Even though there are multiple ways that hackers can sniff packets out of the air, we have some defense mechanisms that are implemented to protect the sensitive information that is being sent. Some of the defense mechanisms include cryptography, key management, secure routing, resilience to node capture, secure localization, and the defenses to counteract DOS attacks. The issue with the countermeasurements for DOS attacks is that many of the defense mechanisms were set up for wireless networks that were static in nature. Due to the fact that wireless medical sensor networks are mobile, the defenses that are currently used to counteract them need further research in order to increase their protection from DOS attacks. As we can see, wireless medical sensor networks are a beneficial tool that allow easy monitoring of patients and allow us to monitor them outside of the hospital environments. While there are connectivity and security issues, they still allow clinicians to access data in areas they previously were not able to. The next topic I will discuss is how the healthcare field utilizes Bluetooth networks to transmit information from sensors to computers. Bluetooth allows multiple devices to connect with each other wirelessly. Bluetooth is a wireless communication system based on radio frequency that allow for either short-range or long-range communication devices. Bluetooth is considered to be a wireless personal area network due to the limited area that allows devices to be connected to each other. As we can see here, the IEEE 11073 standard is the first wireless Bluetooth standard that was accepted by the Continua Health Alliance. Some of the most common uses of Bluetooth we see are in printers, phones, keyboards, and mice that connect to our computers. Bluetooth can also be used with personal computers that connect to one another. They can be bridges over networks, or they can be used as nodes on an ad hoc network. When two or more Bluetooth devices are connected together, they create a piconet, which gives the communication network flexibility and allows us to have multiple devices all on the same frequency hopping spectrum. The reason that we see Bluetooth used as a wireless form of communication is because it is cheap, file sharing is easy over Bluetooth, it has internet connectivity, and it uses low power from its devices. We also see the use of Bluetooth in the medical field because it utilizes an adaptive frequency hopping spread spectrum, which gives it a high interference capability. This means that other devices operating off the 2.4 gigahertz bandwidth, such as Wi-Fi, cordless phones, and wireless USBs, have little effect on the Bluetooth transmission of data. Because we see the utilization of Bluetooth in medical systems, we again must take into account the information that is sent over the wireless personal area networks. Because Bluetooth uses short-range radio, it is very susceptible to attacks. If a person has the same frequency to connect to your computer, they will be able to connect a mouse and a keyboard and essentially look at everything on your computer if they were to obtain the login information. Same goes for a wireless Bluetooth headset. A person should be able to listen into your calls because they are able to connect their Bluetooth device to your phone and you wouldn't even know that they were listening in. There are also other ways that people can access information that you're sending over the wireless personal area network, such as surveillance, unauthorized data access, and sniffing. Because Bluetooth has vulnerabilities, we must implement security protocols that can protect the information that is being transmitted. The way that we can do this is through confidentiality, which allows only devices that are authorized to have access to the information, authentication, which verifies the identity of communication devices. This is important because Bluetooth does not do this naturally. And lastly, we can utilize authorization, which controls the information by making sure a device is authorized before it starts its services. Since Bluetooth is cheap, relatively easy to share files over, and uses low power of its sensors, which is essential because we're using small sensors, it makes sense to utilize this technology in a healthcare field. While there are security concerns with Bluetooth, the benefits that come with it allow the healthcare field to effectively utilize it and that helps clinicians improve the quality of their healthcare. Now, while wireless networks have advantages, it does not mean that it comes with limitations and challenges. One of the first limitations you have to think about is the environmental limitations that limit the ability for wireless networks to connect. Some things to consider that limit connectivity are that these systems are put into older hospitals, lower floors, like in basements, which can make it difficult for signals to connect and penetrate through. Other factors that make it difficult for radio frequencies to connect is how hospitals are constructed nowadays. Hospitals foster a harsh environment for wireless due to radiation shielding, metal doors, and just walls as dividers. Because of all these factors, it has been proven that there is a higher packet loss ratio for the IEEE 802.15.4 standard than in the outdoors. It is also true to say that devices that operate off the 802.15.4 standard are susceptible to Wi-Fi networks, Bluetooth devices, and even cordless phones that are present in hospital environments. Another challenge of these wireless technologies is the reliability of the networks. Many clinicians who use this network believe that wireless equals wired in terms of performance, and that is not necessarily the case. Because networks sometimes have limited throughput, it is difficult to get constant quality when you are sending medical images, records, or large files over the wireless network. And sometimes it can lead to frustration from the clinicians who use it. Other limitations that IT professionals have found on their wireless networks is that when a wireless network drops off or freezes, which can cause people to either restart their programs or find a wired connection. IT professionals also encounter device compatibility issues with their networks and configuring them to people who bring their own device to work. Some hospitals have had to limit what devices their doctors and nurses use by requiring them to buy a specific device, model, and from a specific vendor. Another challenge that needs to be considered is that because devices are wireless and mobile in nature, there's a chance that devices can be lost or stolen. Because mobile devices like phones and sensors are small, they can easily be misplaced or even stolen, which can result in a loss of data or encryption keys. If a device or sensor is stolen or found, the person who found it could use that information in any way they would like, and they could possibly crack the cryptographic keys that could allow a person to decrypt past, current, or future communications. Not only are there challenges with connectivity, reliability, and compatibility, one of the biggest concerns with the use of wireless technologies in the healthcare field is security. Security is such a big issue in the healthcare field because of all this sensitive information that the healthcare field deals with. Not only is information confidential and personal, healthcare facilities that hold medical records must comply with the Health Insurance Portability and Accountability Act, or HIPAA. Because healthcare facilities deal with such private and protected insurance, they must make sure that their wireless networks are secure. Earlier, I talked about security issues with wireless medical sensor networks, Bluetooth connections, and RFID. Now I'll explain some of the general problems that the wireless networks face in general. Because wireless networks don't use wires, there is a lack of physical security for the information that is sent over those networks. Because the signals are broadcasted, anyone who has a device that uses the same bandwidth as the source can potentially intercept that signal and obtain the information that is being transmitted without having to actually physically be connected to the network. Once a connection is established, someone can invade a network and act maliciously inside that network. Another security issue that is associated only with wireless networks is the ability to set up rogue access points. A rogue access point is installed on a network that accepts traffic from other wireless devices. These access points appear to be authentic and can be used to intercept packets that are sent to the rogue access point. Because of the unique security issues with wireless networks, the IEEE 802.11 standard has security features that are built in. One of the first security features that was utilized was the use of wired equivalency privacy, or WEP. WEP was intended to have the same security as an unsecured network. WEP tried to implement confidentiality, access control, and data integrity, but it has been proven that WEP fails to do this effectively. The next upgrade was a Wireless Fidelity Protected Access, or WPA. WPA was just a software upgrade to WEP and was only intended to be a temporary fix to the problems that WEP had. WPA2 was a completely new system and represented the implementation of the IEEE 802.11i standard. While WPA2 is a much improved security protocol, there are still ways that unauthorized users can infiltrate and intercept packets. The reason that this is relevant to the wireless technology used in the healthcare field is because if healthcare providers are using old security protocols or are not finding ways to prevent malicious attacks or programs into their network, that confidential information can be leaked and used vindictively. Because healthcare providers and holders of health insurance have to comply to HIPAA, it is imperative that when wireless networks are utilized in hospitals, they keep the connection secure and confidential so they can protect the information that they have. Our next speaker is going to be Carla, who is going to highlight some devices that are used in wireless healthcare technologies.
Thank you, Matt. Like he said, I'm going to be talking about some wireless devices that we currently use or are in the trial processes. The first technology I'm going to talk about are wireless capsules. These capsules are small pill-shaped devices that allow doctors and physicians to look inside their patients without actually going in and touching all your insides. There are two devices that fall under this category: video capsules and palpitation capsules. Video capsules are small pills the size of a large vitamin that a patient swallows so the physician can examine their small bowel, esophagus, and colon without having to use one of those long rods that you see them use during a colonoscopy. This allows them to have more access because it goes farther and it goes through your whole tract system. The whole tract system is shown by tiny cameras and small light diodes that allow pictures to be taken 5 to 40 frames per second. The data these devices are collecting is either transferred with ultra-high frequency band radio or human body communications. This allows the pill to generate an electric field that uses the body tissue as a conductor. This information the sensors collect is then sent to a receiver, which is later looked upon at a computer. Now that you know what a video capsule does, let's move on to a palpitation capsule. Palpitation capsules restore the surgeon's touch. During surgery, it allows them to go in and measure the tissue pressure so they can find where tumors may lay. The capsule is taking sampling frequencies of 200 hertz, and it creates a 3D visual map of the area so the doctors can look on screen where the tumor actually lays. The capsule is about 1/2 inch wide by 2.5 inches long. Inside it contains a pressure sensor, a wireless transmitter that sends information to an external antenna which records movement, a magnetic field sensor detecting where it's exactly laying, and a battery. The next device I'm going to talk about is the Ensure Wireless AAA pressure measurement system. This device is permanently implanted in a patient's body. It is used to detect the blood pressure internally, and it uses a low power radio frequency to do this. It uses a low powered radio frequency that is activated when a physician waves an external antenna over the area. The information that is transferred is a high resolution pressure waveform that can be seen on a computer. Next, I will be discussing a cardiac device. This device has been created by Stanford researchers. It is less bulky than traditional pacemakers because it does not use batteries to make it run. Instead, it actually uses radio waves. Traditionally, this would not be possible because you need a low frequency and a very large antenna to penetrate human tissue. But Stanford researchers found you can actually penetrate the human tissue with high frequencies. For this device, they're using a high frequency transmitter outside the body with a small coiled receiver internally. This receiver has many coils on it that makes it possible for the two to communicate through the human tissue. Now I'm going to move on to wireless networks that can actually monitor your breathing. Each transmitter uses a received signal strength from the patient's breath to actually detect if the patient's breathing and the rate they're breathing. The transmitters themselves don't do this data, but is transferred to a computer which runs algorithms that allows the network to understand and communicate with how the patient's breathing. In some cases, it can even track what kind of position the patient's in, whether they're standing, moving around, or just laying down. Now I'm going to move on to my next device. This device is a Sensium Vital Band-Aid, also referred to as a digital plaster. Currently, this is a device being used within hospitals to monitor their patients. It is a single-use monitor patch that is placed on the patient. This patch has a 5-day battery life with a 3-hour memory. So technically, the patient could be in the hospital for 1 day and then go home while the hospital still monitors them. If it is not connected to the hospital's network, then the device can only store the data received for about 3 hours, and then it is lost. This device takes the patient's measurements about every 2 minutes, which is exponentially more than is currently done in hospitals because nurses only make their rounds about every 3 hours. With this, we can see a patient's deteriorating signs earlier, so there's less risk to the patient being put in cardiac arrest and having a code blue. The measurements that we see taken with this device currently is the heart rate, the respiration, and temperature. Now I'm going to move on to my next device, which is Philips IntelliVue cableless measurements. Currently, this is only for hospital use, and it's not available in the US. It is similar to our previous device in the fact that it's non-invasive and it is monitoring the patient's vitals. The patients are being monitored without any cables attached to them, so it allows them more mobility and comfort. It can actually allow doctors to see what is happening to a patient, why they're on a treadmill and running various tests, and makes it easier to move patients from room to even surgery. Some of the devices that are in this system are pods. These pods are worn on the left costal arch, which is the area around the bottom of your rib cage. They are used to detect your respiration rate and pulse rate. It uses 3D accelerometer technology to detect these. It can also be used to detect the patient's posture and activity, such things as if the patient's moving, if they're upright, or sitting down. The next device that is connected to this system are cuffs. When thinking about these cuffs, think back to every doctor visit you've ever had, where the doctor is taking measurements of your blood pressure with a cuff. Now with this device, the measurement's no longer manually taken, but electronically taken. And the data is actually sent and stored in a database for the doctor to review later. The next device that is connected to this system is a CpO2 sensor. This device is worn on your finger like the ones that you see in the hospital. When you see someone in the hospital bed, they have this little clip attached to their finger. Well, this one doesn't actually have any cords that's hooking up to the monitor. It is still worn on your fingers, and it is still tracking your oxygen concentration level. But like all the other devices, it is being sent wirelessly to that database that your doctor can review. All these devices are using short-range radio to send the data to your database. The databases that it is working with are either IntelliVue Patient Monitor, which is actually the monitor that's just connected to the patient, so it's not going anywhere else but that monitor, or IntelliVue Guardian software. Eventually, it all ends up in the IntelliVue Guardian software, where the data is stored and managed for later review or current review. Now I'm going to hand the presentation over to my colleague Maria so she can recap what we have discussed with you today.
Thank you, Carla. Now I would just like to go over some of the main points of our presentation for you. Radio frequency identification has changed how everything and everyone functions in healthcare. Tracking for efficiency and effectiveness has greatly improved, and it is one of the main purposes of this technology. Safety has also increased based on preventing counterfeits from entering pharmacies, and more importantly, newborn babies are no longer being stolen from hospitals or being switched at birth thanks to the hugs and kisses technology Kelly mentioned. Radio frequencies are also being utilized in capsules and can see inside people's bodies, which allows doctors to do much less intrusive testing. Networks are now able to detect not only other devices, but other people, which is kind of crazy if you think about it. Wireless medical sensing networks also allow us to do lab quality sensing at home and on the move. This allows us to make the technology more affordable, and the size of the technology is more easily accessible to a larger number of patients in order to improve their healthcare status. In order to improve our security, we've also been using WEP, WPA, and WPA2 on 802.11 networks, and this allows us to have a level of security that is close to or equal to that of wired networks. We also have included a list of references for you at the end of our handout. I'd like to thank you again for your time and consideration. Thank you.